For the circuit, I want to find the value of R for which maximum power will be transferred to it. So that means the value of R has to be the value of the line resistance, if R we see as the load, and essentially the line resistance is the combination of the remaining resistances, and this is the source here. So basically we need to see what resistance if we disconnect R from these terminals. So basically if we draw it like this, the circuit with these terminals open, so that's 10 ohms, 25 ohms, 20 ohms and 5 ohms there, 60 volts there. So what is the resistance that R will see from this terminal? So we want to find Thevenin's resistance basically. So in order to do that, I will make the source short circuited. Since it's a voltage source, it will be short circuited, and so that's 10 ohms. Yeah, that's 10 ohms there, 25 ohms there, 20 ohms there, and 5 ohms there. And we need to find what is the resistance as seen from here, from these terminals. So when we have this arrangement, what will happen is 10 and 20. So basically this one can be redrawn like this. Like this I am redrawing. So this is, let's call it terminal A, let's call it terminal B. So this is terminal A, and that will be 10 ohms and 20 ohms. And this is terminal B. So this terminal and these two terminal are now the same terminal. Now this terminal is not, this terminal is here, which 25 and 5 ohms are connected, but this terminal and this terminal, these are the same through the short circuit. So through the short circuit. So that's 10 ohms there, 25 ohms there and 5 ohms there. So that's actually 25 ohms here, 25 ohms, and these two terminals are the same. So basically we have 10 ohms, 20 ohms in parallel, and 25 ohms, 5 ohms in parallel, and then they are in series. So the resistance seen, R Thevenin's, will be 20 parallel 10 plus 25 parallel 5. And this one is, if we put the expression, so that will be 20 times 10 over 20 plus 10, 30, plus 25 times 5 plus 25 plus divided by 25 plus 5, which is 30. So that will be 6.67 here, and then 4.167, like something like that, and then it will be 10.83333. So I will just write 10.83 ohms. So that's the value of the Thevenin's resistance. So this will be the value, this is the value of the line resistance for the resistance R from this terminal. So the value of R has to be also the same, so that maximum power is transferred to it. The line resistance and load resistance has to be same, so for maximum power transfer. So that's the value of R. So we have now the value of R, but we need to we actually can work with this one as well, but what I will do, I will probably find Thevenin's theorem just to see Thevenin's voltage, sorry. So basically it's the same circuit now. So 60 volts there, and then again 10 ohms, 10 ohms, 20 ohms, 25 ohms, 5 ohms, and this is connected here. Now we need to find what is the value of these two terminals, what is the value of this voltage, open circuit voltage, VAB, which is Thevenin. So once we have that, it will be easier to find the power dissipated, in my opinion, but I will work like that. Okay, so here we have just two parallel paths. When the current comes here, there are two parallel paths, and one is this way, another is this way, and then the currents are combined here again and goes back here. So these two parallel paths, this one 10 20 in series 30 ohms, 25 5, these two in series 30 ohms. So basically we have two 30 ohms parallel path. The combination of the resistance will be 30 parallel 30 is of course half, so that's 50 ohms. So the total current that is coming out of the source will be, so I out of the source will be 60 divided by 15, which is 4 amps. Now these 4 amps will be divided equally between two parallel paths, because the parallel paths resistances are the same. So we have 2 ohms in this direction, 2 amps sorry in this direction, and 2 amps in this direction, 2 amps. So we have a voltage drop of 20 volts across the 10 ohms resistance, 10 times 20, and we have a voltage drop of 25 times 2, 50 volts across the 25 ohms resistance. So these two drops we know. We can calculate the voltage of VA that way, 60. So if we start from here, this is a ground. So 60 volts rise here, and then up to going in this direction up to VA, we have 60 volts minus then the drop in the resistance, which is 20 ohms. 20 volts sorry 20 10 times 2, which is 20 volts, so that's 40 volts. That's the voltage of VA. And VB will be, which is the other parallel path, 60 volts, and then here across the 25 ohms the voltage drop is 50 volts, so that will be 60 minus 50, which will be 10 volts. So we have VA, voltage of VA and VB, so VAB will be, of course, 40 minus 10, which is 30 volts. So that's the Thevenin's voltage. So we have now the complete circuit, Thevenin circuit, 30 volts here, and then resistance is 10.833, 10.833. So this is the Thevenin's resistance and or the line resistance, and this one is the value of R, and we need to find what is the power dissipated by R. So PR will be, of course, I square R, and I will be 30 divided by 2 times 10.83, like that, and then so that's square times 10.833, 83. So it goes like 8333, so I'm just writing up to 2 decimal points, so like that. And this one PR becomes, from the expression, from the 20.77 watt. So that's the power dissipated by the resistance R, and this is the maximum power when the resistance have as such a value, so that the maximum power is dissipated, or we can say the maximum power dissipated by the resistance is this one.